Bismillahirrahmanirrahim. Today we will discuss experiment number 4, which is taper turning operation on CNC lathe machine using CNC simulator software. In this experiment, we will first learn what is taper turning, and then we will run a code for taper turning. We will write the code like we did in the previous experiment, and then we will check our written code on CNC simulator software for any error. Then after completing the code and checking on it in CNC simulator software, we will run this code on our CNC lathe machine. In taper turning, the diameter of the workpiece uniformly changes from one end to another end. Like in this picture, we can see that the diameter is continuously decreasing from left to the right end of the workpiece. Tapers can be either internal or external. If a workpiece is tapered on the outside, it has an external taper. Similarly, if it is tapered on the inside, it has an internal taper. This can be done with the help of the boring tool. Normally for taper turning or outer taper turning, the compound threads of the lathe machines are used. I have used the last slide from the machine shop introductory lecture in which the taper turning is discussed in detail. Now moving towards the experiment, this is our raw material, which dimension is 100 mm by 40 mm, and this is our finished job. As discussed in taper turning, the diameter uniformly changes. We can see here from left to right, the diameter is continuously decreasing. From left end, it is 40 mm, and at right end, it is 25 mm diameter at the start and decreasing to the 10 mm. So there is a step of 40 mm and 25 mm. As in the previous lecture of step turning, we have discussed step turning in detail. Here is the same. This is a step of 25 mm to 40 mm. Here diameter is 25 mm and the next part diameter is 40 mm, and the end part the diameter is continuously decreasing uniformly from 25 mm to 10 mm up to length of 70 mm. So how we will do this? We will write a code for this process in the coming slides. In the last slide, I think I missed the word of taper turning. So you can see from 40 mm to 25 mm, this is step turning, and from 25 mm to 10 mm, this decreasing dia uniformly is the taper turning. This process is taper turning. Okay, in taper turning, diameter continuously decreases from left to right and in this case. So this is the taper turning in which dia is continuously decreasing from 25 mm up to 10 mm. This is taper turning, and this one is step turning. Here diameter is 25 mm and there diameter is 40 mm. This is step turning, and after step turning, this whole length is done by taper turning operation. Now starting with the CNC simulator, first you will open the CNC simulator software. Then you will click on the top right side on the icon File Manager. Then this window will appear. Now there are three options you can see. The Open Project is option used to continue work from previous session. I mean, if you have already a job saved, you can open it from this option. The Save is for saving the current progress, and New Project is for starting new job. After starting the new project, you will set now the workpiece parameters. For this, you will click this icon. Here, second right top side. This window will appear. Now, this is the workpiece length. This is the initial length of our raw material, which I have set 100 mm. This is the workpiece diameter, which is the initial diameter of our raw material, which is in this case 40 mm. This is the clamp length. Clamp length is the length inside this chuck. Here you can say the length of the raw material inside this chuck is known as the clamp length, which I have set 20 mm for good clamping. We have set all the initial parameters of our raw material: 100 mm length, 40 mm diameter. All these are the initial parameters of our raw material. After setting the workpiece parameters, now you have to select the tool parameters. For this, you will click this third icon in the figure. This is for the tool selection. When you click this icon, this window will appear. here you can see you have different options for tools. For turning, facing, there are different tools. Now in this case we will select this 5 number tool, which is for general turning and facing. For selecting the tool, you have to drag the tool like in this way. From here you drag the tool this like and put it there. By doing this you have selected now the 5 number tool, which is for general turning and facing. We have no need to change these parameters of the tool. You can see that there are options for selecting other tools like 2, 3, 4, 5. These are used for selecting multiple tools. Like you have studied that in tool posts, multiple tools can be adjusted at one time. So this option is used for selecting multiple tool selection. Now before starting the coding, I will summarize up till now what we have done. First, we have opened the CNC simulator. Then we have opened the new project. Then from here we have set the workpiece parameters, this option. Then from here we have selected the tool. I think I missed this highlighting option in the previous slide. So this is the third option for selecting the tool. Now the fourth option, this is used for the coding. You have to, when you will click this icon, a new window will appear like this. I have written the code, but when you will click this icon, there will appear a new blank window. Okay, then you have to write the code for the facing operation, or what operation you have to do. I have explained this coding in the later slides, but here I will tell you for every code there are three parts: the first part, the middle part, and the end part. This is the first part of the program, like the from here this line to this line. This is the first part. This is the middle part from this line to the this line, and this is the end part from this line to this line. The first part of the program is generally used for switching options, like which units you are going to use, metric or inches, similarly to switch on the coolant. While the middle part is related with the workpiece details. You will define workpiece here like its length, diameter, which option you have to perform. All these details will be written here. In the end part, you will now close the program and other things like if the coolant is on, you will write the command here for switching off the coolant. Similarly, M30 is used like this line, it is used to close the program. For writing the program, you can use your own keyboard, and also the simulator on option for writing can be used, which I have discussed in detail in the coming slides. This is the keyboard of CNC simulator software I was talking about in the previous slide. This is the icon in the bottom taskbar. By clicking this icon in the bottom taskbar of the CNC simulator software, where the writing code option is, this keyboard will appear. As you can see, this keyboard covers almost all the required alphabets, and all numbers are present in the keyboard. Also, other necessary buttons like enter, delete, and backspace is also present. Here, brackets are also present. So you can see you can use this virtual keyboard of CNC simulator, or if you don't want to use this, you can use your own laptop or a computer keyboard. It's up to you which keyboard you want to use for your own comfort. This is the complete code for taper turning operation. You see again here some slides the lines are same like 0001 and 10. Some commands are still same S500 M03. Uh, this one is the new. This line is new. This is the taper turning cycle, which I will discuss in detail in the coming slide. Rest you see M03, M30. The commands are repeating. So these commands are always repeating in the every operation. It is better to you memorize these commands. Now starting with the code explanation, I will start with the very first line, which was 0001. This line is the start with the code O, and it O 0001. While writing a program on unicontroller, first line has to be start with O letter. It will always followed by a four-digit number. The number specifies from 0001 to 9999. I mean, this is the range of the its own code. Whenever you write a program, it always have to be specified by specific number. So in the very first line, we will specify our program code by giving it a specific number. Now moving towards the next line, this is the N10, G21, G19 and G40. Starting with the N10 line, whenever N code is used, it is used to define the name or title of block of G code, or simply it defines the line number. So N10 means N line number 10. The next is G21. G21 code is used to switch between the metric system of units. So when we have used G21 code, so every dimension written in the code will be considered in millimeters. It is used for metric units in millimeters. G99 code G99 code select the units of the feed rate. So whenever in the code you have given the feed rate, it will consider it in millimeter per revolution. So we can say that we have now set our units in millimeter and we have set our feed rate in millimeter per revolution. Every value you give in the code, the length of your dimension will be in millimeters and the feed rate will be taken automatically in millimeter per revolution with the help of G21 and G99 code. G40 code is used for tool radius compensation. There are two other codes, G41 and G42, for left and right tool radius compensation. But here, with the help of G40, we are selecting automatic tool radius compensation. Now the machine will our CNC will automatically select the tool radius compensation according to the our tool and workpiece. Now discussing about G00 code. This code is used for the rapid G00 code is used for rapid positioning of tool. For example, if the tool is away from the workpiece, by using the G00 code, the tool will rapidly position towards the workpiece. This is the purpose of G00 code. G28 code G28 code is used to move the tool to a reference point. Initially, we will set a reference point for the tool. So when we use a G28 code, after the work is finished, the tool will move to its reference point, which we have set earlier. U0 and W0, these are the secondary movements about Z and Y axis. These are used to move the tool in the X and Y axis according to our positioning. Now starting with the next command, this was T0101. Normally T command is used for changing of tool. As we have discussed earlier, there are a number of tools, almost 4 tools can be applied at different tool posts. So T command is used for changing of tool. Here the first two digits 01, it represents the tool number 1, and the second 01, this number represents the offset number. It means we have tool number 1 at one position. I am calling my tool which I have numbered in number 1 position to offset number 1 for the facing operation. So whenever T command is used, it is used for changing of tool. It can be 01, 02, 02, 01. Different tools at different numbers. Always remember the tool position for calling the specific tool for specific operation. Like I have installed my tool at first position in the earlier slides, so I am recalling it from the first position. The next line is G96. G96 is used to rotate the spindle at constant RPM. So here you see the next code is S500. Both commands together means now the spindle will rotate constantly with the RPM of 500 revolution per minute. The rotation unit revolution per minute was selected in the previous slides. The next is M03. M03 is used for selecting clockwise rotation. Its opposite is M04, which when applied the spindle will rotate in anti-clockwise direction. Now X42 and Z2, this command is new here. For explaining the command, I have to draw the workpiece. So let me draw the workpiece. Uh, let's suppose this is your workpiece and this is x-axis perpendicular to the workpiece, and this is the z-axis. So X42 and Z42, these are used to give the initial points to the tool. As you remember, our diameter was 40. So let me write, our diameter was 40 and the length of our workpiece was 100 mm. And this length was 100 mm. So by X42 and Z2, what will happen? Our tool will move 2 millimeter away from the workpiece in X direction and 2 meter away from the workpiece in Z direction. Let's suppose this is our tool. Here, this is the point. This is a point. There will be 2 mm clearance in both axes. From Z axis, it will be 2 mm away from the tool, and from X axis, it will be 2 mm away from the workpiece. Our tool will be, this is gap is 2 mm. So by giving that command of X42 and Z2, our tool will move just to this point 2 mm away from the workpiece. When we start cutting, it will then cut the tool in both direction, because our workpiece will be rotating, and with the movement of tool it will be cut in both direction, in circular direction uniformly. No G90 command. This command is used for turning cycle. This cycle is used for stock removal in parallel tool path. For explaining this, let me draw the workpiece. Now suppose this is your workpiece and this is your tool. Now parallel tool path means for reducing the dia, your tool will move in this direction and along the z axis. Remember the axis I have drawn. This one was your z axis and this one was your x-axis. Now what will happen with the help of using G90 command? There are four options. Four different steps are going to be performed in G90 cycle. Rapid to X position. A rapid to X position, it will give the tool movement in X direction, in this direction. In the last slide I said the X direction was perpendicular to workpiece. Basically X and Z are perpendicular to each other. I have been mistaken in the last slide. So X and Z are perpendicular to each other. Rapid to X motion, this will give the tool motion in this direction. And feed to Z position, feed will give the movement to the tool in this direction. So first our tool will move into the workpiece for cutting, and with the help of Z feed it will move in this direction. Similarly, feed to start X position, when our required cut is finished, tool will move back to the initial position, and rapid to start that position, then it will again move into the workpiece, and this cycle continues. I will explain the cycle in the next slide. This is our turning cycle. These four commands are explained in the next slide too. Here's the cycle line, the four distant moves with one line of information. These are the four distant moves which are explained in the next slide too. Now we will discuss the G90 code used for taper turning format. This G90 code is same as we are using in previous lectures. We used it for tracing cycle, we used it for step turning and turning cycle. Now what is the difference here? This new value, or this is the difference here. What is R? Now R is the capital D minus small d divided by 2. This capital D is major diameter and this small d is minor diameter. What are the major and minor diameter? As you remember in the early slide, we have selected our raw material workpiece of dia 40 mm. So this 40 mm is the major diameter, and we have to reduce it to the 25 mm diameter. So this 25 mm is our minor diameter. So by putting values in this formula, we have calculated value 7.5. So this is the value of R, which is 7.5. And this R will be used here for taper turning process. Rest all is same. This X value we have used earlier, this Z value we have used earlier, this F is the feed rate. So all this code is same, but the only new thing here introduces the value of R, which is used for here taper turning cycle. Now explaining the G90 cycle, first we will draw axis. This one was your x-axis and this is your z-axis as we have used in previous lectures. So for the command uh, x40 and z minus 70, uh, when in the start you will start the turning cycle, this whole workpiece will be of 40 length, like it will be like somewhat like this, 40 from this end and 40 from this end. So when you will give it the command of x40, what will happen? The tool will move with the help of x40 and z minus 70. The tool will move from this point to this point at this point. Now at this point, I am showing you red color. At this point, the red one, the x will be 40. It means your diameter will be 40. At this point, z will be minus 70. The tool will move this distance from this point to this point. This distance will be 70 mm. Z minus 70 means that, but with an angle of minus 7.5 mm. The value of R will be minus 7.5. So this value will give it the taper turning shape. Like it will be like this, like, and same like above side. So what will happen? The tool will move from this point to this point to this point, length of minus 70 mm. At here the tool will stop at a distance of 40 mm. So at this end the diameter will be now 40 mm, but at this end the diameter will be now 25 mm, because the two we have given the dimension of minus 7.5. So minus 7.5 from the downside and minus 7.5 from the top side, so it will remove the diameter of total 15 mm. So 40 minus 15, now the diameter at this end will be 25 mm. The first cut will bring it to 25 mm from this side, and this side will be 40 mm. Now for the next cycle, what will happen? This is x35. Now our tool will move the same distance minus 70 mm, but up to x35. It will bring the tool to x35 somewhat above the minus 40. Now this line will be cut off like this one. So in the first cycle the diameter was reduced, and no diameters were reduced at this side, but in the second cycle here the diameter is now 35 mm, and at this end the diameter will be now 20 mm, 2.5 from above, 2.5 from the bottom side. So total diameter removed will be 5 mm from right end, and at the left end 5 mm removing from the 40, it brings it to 35 mm. In the next again cycle, let me choose another color, the green line. In the next cycle, now the diameter at left end will be 30 mm, x30 at the left end, and removing from the right end. The first time it was 25, the second time it was 20, now third time it will be 15 mm, removing 5 mm from both sides. From right hand it has now reached up to 15 mm, and from left hand it has now reached up to 30 mm. In the last and final cycle, the diameter will be now 25 mm, x25. X25 means at this end now. At this end the diameter will be 25 mm at left end, and removing 5 mm again from the right side, from 15 it will be now 10 mm at this side. So you see, in the 4 different steps, with the help of R value, we have cut it in the taper turning format. We have reduced the diameter at one end up to 10 mm, at the other end it is now 25 mm. So let me summarize the whole command. We have started from x40. The first line x40 has reduced the diameter this end x40, and at this end the diameter was 25 mm. In the next command, the diameter was x35. Now this side is reduced to x35 mm. At this end, the diameter will be 20 mm. Now in the next cycle, the diameter was reduced to x30 mm. Now this side was reduced to 30 mm, and at this side the diameter is 15 mm. I have written it there. Now in the last and final cycle, the diameter was reduced to 25 mm, which was our required diameter. This side is now reduced to 25 mm, and this side is reduced up to 10 mm. This 10 mm. So in the four different cycles, we have reduced the diameter from 40 mm to 25 mm on one side and 10 mm on other side with the help of G90 taper turning cycle. This oblique line is this line as angle is due to this R value which we have given the minus 7.5, and this 70 is the length on which we are working. This whole length 70 mm. Minus direction shows the tool will move from right to left hand. Now f 0.5, this was the feed rate like we used in the previous cycle for facing and turning. M08, this is for coolant down option. So I hope you have got the turning cycle, taper turning cycle. If you have any confusion, you can see the video in the last slide, but it is not so difficult. At this end, we have reduced to have first 25, then 20, then 15, then 10 mm, 10 mm. This is 10 mm, and here we have moved from 40, then 35, then 30, then 25. At the end, this is 25. So 25 mm there and 10 mm there. This was our taper turning cycle. Here I have added some pictures again for more clarification. You see this is X40, 35, 30, 25. This is that diameter X40, 35, 30, 25. And one by one in each cycle the diameter is reducing from 40 to 35, then 30, then 25. And on the other hand, due to this R value, that diameter is reducing from 40 to 25, then 20, then 15, then 10 mm. So this one is our final part. You can see in all these parts the length is same. There is no change in length. Only the diameter is changing. On the one side it has reduced from 40 mm to 25 mm, and on the other hand it has reduced from 25 mm to 10 mm. So this was the uh, case I was talking about in the previous slide. In these four passes, you have reduced the diameter from 40 mm to 25 mm on one side and 10 mm on the other side. This is our final job. This picture is the our last and final job workpiece. Now coming towards the end of the program, we will use G00. It is almost same for all operations, but only difference is for value of x and z. In the last lectures, we have used this command to G00. What does it do? It gives rapid linear interpolation position of the tool to a point. Basically, it moves the tool away from a point, away from workpiece to a specific point. Here I have set the coordinates x42 and z5. So our tool will move to these points x42 and z5 away from the workpiece. And M09 is used for coolant off. These x and z values are basically the coordinates. We can set these coordinates according to our workpiece. For example, our workpiece dia was 40 mm. So I have selected x42 to move the tool away from workpiece. Similarly, z5. So these are the coordinates of the tool. Here I have mentioned these points to x42 and z5. G28. If by chance if you have not used G00, and then G28 reference point returns the tool first to G00 position. This is often known as intermediate position to which tool is returned. Then after G00, it will go back to the home position. Here reference points U, W, these are along about X and Z axis. I have selected both 0, 0. So the tool will now return to X0 and Y0. At the end there is M30. M30 is used for the completion of the control program. it is always used at the end of the program. Now here our program is complete at M30. So far your coding is complete, your program is complete. Now we have to run the simulation for checking if any error is there we can notify. Uh, this is the play button. From here you can run the simulation. So if there is any error it will be notified. As discussed earlier, before working we will run the simulation for checking the error. Here is the pause and stop button. If you want to pause or stop the program you can use these buttons. And this bookmark icon, this is used if you have any confusion regarding any code, then click this icon. The detail for every code will be available to you for checking of any code or any other information regarding the code. Up till now your work is complete, your code is complete, simulation has been done. So now we have to save the project. Again click the topmost icon in the right side. By clicking this icon this window will appear. Here you will click the save project. By clicking this option you will save the current all progress. Remember that don't use space in between the alphabets. Always use underscore sign because the space sign will not be read by the software. So use underscore sign in between the alphabets if you have to use them. Also in the next slide there is complete video for the program written along with running simulation. Each step is described live one by one for better understanding. So if you have any confusion so far, please see the video in the next slide recorded in Urdu. A video will give you the detail of every step with running simulation. And thank you.
फर्स्ट ऑफ ऑल हम जो है वो फाइल मैनेजर पे क्लिक करेंगे, न्यू प्रोजेक्ट करेंगे टिपर टर्निंग के लिए, और उसके बाद हम वर्क पीस के पैरामीटर को एडजस्ट करेंगे। तो हमारे पास वर्क पीस की लेंथ 100 mm है और जो डायमीटर है वो हमने 40 mm रखना है वर्क पीस का, जो कि हमारे पास जो है त्रिज्या चक में होल्ड है। और जो क्लैंप लेंथ है हमारी वो हमने 20 mm रखनी है। और ये जो हमारे पास जो त्रिज्या चक है इसके अंदर ये लेंथ जो कि क्लैंप लेंथ है वो 20 mm होनी चाहिए। उसके बाद जो है हम जो है अपने टूल्स के पैरामीटर पे जाएंगे। अब हमने टूल्स को सिलेक्ट करना है कि कौन सा टूल होना चाहिए टेपर टर्निंग के लिए। तो उसके लिए नंबर 5 पे जो हमारा टूल है टूल कैटलॉग से आप तलाश करेंगे जनरल टर्निंग एंड फेसिंग टूल, इसको ड्रैग करके आप लाएंगे और 1 पे प्लेस कर देंगे। अब ये आपके पास बेसिकली एक टूल है, इसका ऑफसेट ये मैक्सिमम पे है, अगर आप इसको कम करेंगे तो ये आपके सामने नीचे डाउन पे जा रहा है। हम इसको दोबारा फुल मैक्सिमम पे रखेंगे जो कि x इक्वल टू 90 पे है। इसके बाद हम जाएंगे कोड एडिटर पे। बेसिकली यहाँ पर हमने अपना प्रोग्राम को राइट अप करना है। तो राइट अप करने के लिए सबसे पहले आपने नीचे पे क्लिक करना है, जो आपका आइकन है इस पे आप मैनुअल भी इस पे लिख सकते हैं और बाय पेस्ट भी कर सकते हैं। इसके बाद हम ज़रा अब इसके डिफरेंट व्यूज़ को, कैमरे के व्यूज़ को देखेंगे। तो उसके लिए हम ये जो है इसमें जूम इन कर रहे हैं। ये आपके सामने त्रिज्या चक है, ये आपका वर्क पीस है। और वर्क पीस अब आपको इसमें टूल की लोकेशन नज़र आएगी। ये हमारा जो है वो टूल है जो कि टर्निंग टूल है, और इसने जो है इस वर्क पीस के ऊपर वर्कआउट करना है और इसके टेपर टर्निंग का ऑपरेशन जो है परफॉर्म करना है। बेसिकली मैं ये कैमरा नंबर 2 की सेटिंग को एडजस्ट कर रहा हूँ ताकि मैं जब इस प्रोग्राम को रन करूँ तो मेरे लिए जो है वो एक बेटर लुक जो है वो वर्किंग के दौरान नज़र आए। तो जैसे कि आपको नज़र आ रहा है नंबर 1 पे हमारा जो है वो टूल एडजस्ट है। इसको टर्रेट ٹول پوسٹ کہتے ہیں، اس میں آپ ڈفرینٹ 8 ٹول لگا سکتے ہیں، آپ کے سامنے ہیں۔ تو یہاں سے میں پروگرام کو رن کیا، آپ کے سامنے ہے، اور یہ ہمارا 3 چک جو ہے وہ رن ورکنگ اس کی سٹارٹ ہوگی۔ اسپنڈل سپیڈ جو ہم نے 500 mm رکھی تھی، یہ ہمارا کولنٹ آن ہو گیا، اور یہ ہمارا جو ہے بیسکلی جو ٹرننگ ٹول ہے وہ ٹیپر ٹرننگ پرفارم کر رہا ہے۔ بیسکلی ریڈیس کی جو ہم نے اس میں کمپنسیشن 7.5 دی تھی، تو اسی حساب سے وہ اس کو ٹیپر کرتا رہے گا۔ یہ ڈفرینٹ کیمرہ کی لوکیشنز آپ دیکھ رہے ہیں، اس میں جو ہے کولنٹ آن ہے، ہمارے پاس 3 چک کی ورکنگ ہو رہی ہے، اور ہمارا جو ٹول ہے وہ ٹیپر ٹرننگ پرفارم کر رہا ہے۔ اب ہم اس کے کیمرہ نمبر 1 میں جا کے دیکھتے ہیں، جو کہ 2D ایک بیسکلی ایک کیمرہ ہے۔ اس میں آپ کو یہ اس کی ورکنگ کرتے ہوئے نظر دکھا رہی ہے کہ کیسے جو ہے وہ ہمارا جو ٹول ہے وہ ٹیپر ٹرننگ کو پرفارم کر رہا ہے۔ سو بیسکلی ہم کیمرے کو چینج کریں گے، یہ کیمرہ نمبر 2 ہے ہمارا۔ کیمرہ نمبر 2 میں آپ دیکھ رہے ہیں کہ سیم آپ کے سامنے جو ہے ورک پیس جو ہے وہ ریوالو ہو رہا ہے، اور جو ٹول ہے وہ لینئر جو ہے وہ اس کو پیرالل یونیفارملی اس کے ڈایا کو جو ہے وہ ریڈیوس کر رہا ہے۔ اور یہ ہمارا پروگرام کا اینڈ ہو چکا ہے۔ اب ہم اس پروگرام کو کلوز کرتے ہیں اور اس کی 2D ڈائیگرامس کو دیکھتے ہیں۔ بیسکلی یہ ہماری فائنل آؤٹ پٹ ہے، اور یہی ہماری ریکوائرڈ شیپ تھی کہ ہم نے اس کو ٹیپر ٹرننگ کرنی تھی۔ بیسکلی یہ ہمارا ورک پیس کا جو لیفٹ آپ پہ نظر آ رہا ہے 40 mm کا، اور بالکل رائٹ سائڈ پہ جو ہے وہ 10 mm کا جو ڈایا ہے۔ تو بیسکلی ہم نے یونیفارملی اس کے ڈایا کو ریڈیوس کیا ہے فرام لیفٹ ٹو رائٹ سائڈ، and that is the lathe machine, CNC lathe machine.